Hello. My name is Ram Nivas Yadav. I am BTech from IIT Patna. So today I am here to teach you one of the most confusing topics of physics, that is friction. So we will understand this basic concept of the friction and then move on to some to solve some problems. So here is about me. I am Ramya Sadhu from BTech IIT Patna, and here is I am district topper, cleared JMS advanced, mentored 100 plus students in our college, and then I was also in the teaching team of NSS IIT Patna, and I was a 2 year classroom student during JEE preparation. So let's move ahead and start the topic. So let's understand this concept of friction with one experiment. Okay, let's see one experiment that here is ground surface and this is one block, this is one body whose mass is m, whose mass is m, and force, here is one force applying on this body, that is f. So basically, we have studied that when there is force on the body with mass m, then this should move with acceleration a in the forward direction with this equation f is equal to ma. But what I am finding is that when I am applying a force, let's say I am applying some force f is equal to 2 Newton. Then I found that the acceleration is 0 Newton. Why? Okay, so let's increase the force. Then I increase the force to 4 Newton. Then also I found that the acceleration is 0 Newton. What happening is that we are applying a force on this, but it is not moving. It is because that there is some force between this surface and this body that is stopping it from moving, and that force is called friction force. Let's explain it. That force will be called as friction force, and whatever 2 Newton I am applying on this body, this 2 Newton, this 2 Newton is getting taken by this friction force, which is acting between this body and the surface. Okay, so this 2 Newton will be going here as a friction force, and this 4 Newton will be also going here as a friction force. So I want to know that on which force this body will start moving. Then I started applying 5 Newton, 10 Newton. Then also the acceleration was 0. Then I applied 10, 20 Newton. Then also I found that acceleration is 0. And we know if acceleration is 0, then it means this force whatever I have applied here is taken by the friction, and that will be, then friction force will be 5 Newton, 10 Newton, 20 Newton. Then I found that if I increase the force to 21 Newton, then it started moving. Then it started moving. There was some friction force. There was acceleration, so that it started moving, and there was some friction force acting on it. Then I increased the force to 30 Newton, and then also there was some acceleration and there was some friction force. So what we are seeing here is that when when the when the body was not moving, then the friction force which was applying here was the static friction, was will be called as static friction. And when the body started moving, then whatever force here, friction force is applying between this body and the surface will be known as the kinetic friction. So let us understand it in more depth by making one graph. Let's understand its function, how it is changing, how friction force and the force we are applying on the body is varying. So we are saying that initially whatever force we were applying is getting converted into the friction force. So there is a linear relation between this. There will be a 45 degree, it will form a 45 degree with this x and y axis. Then after that, in the experiment, they have found that the friction force which was applying initially is what it was increasing, but once the body started moving, the friction force which is applying here will be called as kinetic friction, and this kinetic friction which is getting acting on this body is constant. From experiment, they have found that the force when the body started moving is is constant, and this is less than this static friction maximum value of the static friction, and this will be called as the kinetic friction. This will be called as the kinetic friction. So what we can say that, let's see the difference between this static friction and kinetic friction. And from graph, it is clear that the static friction value is maximum value of static friction is more than the kinetic friction. Let's see the difference between these two more clearly. Sorry. So let's say there is static friction. So here we are seeing that the friction is of two types: static friction and kinetic friction. And kinetic friction. In static friction, what we have seen that its value is not fixed; it is variable. It is variable. It's increasing. So it has a variable variable value. And what we have found is that it is not that it always increasing, it is increasing up to certain limit only, and then it is stops increasing. So it has a variable value, and has a certain limit. Okay. And and this will be a static friction. There will be a certain limit that we are seeing will be the maximum value of the static friction, and maximum value of the static friction is also called as limiting friction. Limiting friction limiting friction. And from the experiments, they have found that this static friction, maximum value of static friction, is directly proportional to the normal force. What is normal force? Normal force is the force when this what happens is that this due to acceleration there will be mg on this ground, and there will be a normal force acting on this body due to the reaction of the ground surface. So what we have found that this is directly proportional to the normal force, and maximum static friction is equal to mu s into n when we remove this proportionality sign, and this mu s is known as coefficient of static friction. Okay. And similarly, in the kind when we see in the kinetic friction, then we have seen that kinetic friction has a fixed value. Its value is constant, not changing. So it has a constant value. Constant value. And kinetic friction is denoted by Fk, and this is also directly proportional to normal force between the body and the surface, and this Fk will be equal to mu k into n, and this mu k is called as coefficient of coefficient of kinetic friction. Okay. So what from here what we can say that this static friction is self adjustable, means it adjusts its value depending on the force what we are applying, self adjustable. Okay, so let's see the definition of this static friction and kinetic friction. Static friction when this is acting and when this kinetic friction is acting. We will see here when one short one line definition that when we can say that the static friction is acting and when we will see that the kinetic friction is acting. So it act when when there when there is no relative when there is no relative motion motion and there is no relative motion between the surface and it act kinetic friction will act when there is there is relative motion between the body and between body and surface. Here you can see that we are saying that this is relative motion, not the motion only. Why relative motion? Let's see that when when there is a two body, let's say here is one body and here is one more body. When we are applying force here, then this body is also moving, but with relative to this surface, this is not moving, this is moving with relative to this surface. So we in friction we will always talk about the relative friction between the surface, relative motion between the surface. So this is moving with respect to this surface. Okay, now let's see these concepts with the numericals so that we can understand it in more depth. Let's see that there is a surface and here is the mass which is equal to 10 kg. Let's say its mass is 10 kg and here is we are applying a force of 10 Newton. Force of 10 Newton. Then what happens is that, and they have given that the coefficient of static friction is 0.4 and coefficient of kinetic friction is 0.3. So let's find what will be the value of static, maximum value of static force. This what we have seen, the formula is mu s into n. Then what will be the mu s? Let's see that here is mg and that is equal to 100 Newton. Mass is m, g is 10, and this will be, there will be a normal force that will be equal to the 100 Newton that we have already studied in the NLM. So here we will take mu as static friction value is 0.4 into 100. This is 40 and kinetic friction value will be mu k into n. This is equal to 0.3 into 100, that is equal to 30. So what we can observe from here is that to move this body we should apply a force greater than equal to 40 Newton, then only this body will start moving, otherwise it will not move. There will be zero acceleration. So to have any acceleration for this body we should have a force greater than equal to 40 Newton. Let's say we are applying a force of then 50 Newton, then what will be the acceleration? So acceleration will be force. And see, when the body start to move, then there will be a kinetic force. Then when the body is in motion, relative motion, then the friction force that is getting applied will be known as the kinetic. This friction force will be kinetic friction when it start to moving. So for motion, here we will subtract the kinetic friction value and divide by mass, and this is equal to 50 minus 30 divided by mass is 10, so this will be 2 meter per second square. So what we have seen, before 40 newton there will be acceleration will be 0. For f less than 40 newton acceleration will be 0, and for f greater than 40 newton there will be some acceleration, and we have proved it from this numerical. Okay, so let's solve some more problem on it. Let's say I have a brick block, again a block m is equal to 10 kg only, and here I am applying a force of 100 newton, but it is at an angle 37 degree. So what will happen is that, and this same mu s is uh, point point 4 and mu k is zero point 0.3. So what will be the acceleration? Find value of acceleration is equal to what? So let's solve this problem. First take the component of this force. This will be in this direction, f cos 37 degree, and that will be equal to 80 kilonewton. Here is f sin 37 degree, and that will be equal to 60 newton. So what, to find the, we know that the friction is directly proportional to normal, so we need to find the normal force here, and there is mg, this is equal to 100 newton, and normal force will be in the upward direction, that will be equal to, let's calculate what will be the normal force, because here we see that there is one more force acting here, so we need to be careful here while calculating the normal force, because the normal force will be equal to n plus 60 is equal to 100. Then here normal will be 40 newton. Here normal will be 40 newton. Now let's find the fs max value. Fx max value will be mu s into n, that is zero point 0.4 into 40, 60 newton, and fk, fk is equal to, kinetic friction is equal to mu k into n, that is 0.3 into 40, that is 12 newton. So what will be the acceleration of this body? Acceleration is F minus kinetic friction divided by m, because the here one friction force will be applying, and that will be kinetic friction, because this force 80 newton is greater than the maximum value of static friction, that is 60 newton. So from comparing this, we can say that this, there will be a acceleration on this body, because the force applying is more than the static friction value. So F is 80 newton in this direction, there is 80 newton force, and there is a kinetic friction of 12 newton divided by 10, that is 68 68 6.8 meter per second square. So now we have understood the difference between the kinetic friction and the static friction very clearly, that this graph was, initially we have understood this graph, it was most important one to understand, that. So now let's end this session, and we have understood the friction and kinetic friction. Okay, so thank you so much.